Welcome to the Explainer. Okay, today we are taking a totally exclusive behind-the-scenes tour through a modern machine learning factory. If you've ever wondered how raw data actually gets transformed, trained, and then perfectly packaged into a lightning-fast app, well, you are exactly in the right place. We're going to deconstruct this fascinating project called SENTINALysis, and we'll unpack the exact pipeline they use to build a completely production-ready sentiment analysis engine. It's going to be fun.
And the developer outlines their ambition perfectly, right there in the documentation. Quote, "This project implements a complete sentiment analysis system using a pre-trained BERT model. It includes a full MLOps pipeline." End quote. So listen, we aren't just looking at some isolated Jupyter notebook here. No way. We're looking at the whole shebang, the entire life cycle. We're taking a Twitter sentiment model from raw data, pushing it through local training, and shipping it all the way to a fully deployed, containerized application.
Okay, let's dive into this factory map. 1. Meet the SENTINALysis pipeline. 2. Choosing the right model. 3. Training the sentiment engine. 4. Deploying with Docker. And 5. Making real-time predictions. Let's get to it.
Section 1. Choosing the right model.
So our very first stop on the assembly line focuses on the core machinery itself. The developer made a really highly calculated engineering decision here. They chose to use DistilBERT instead of the massive standard BERT model. And honestly, it all starts with this one number, 97%. DistilBERT miraculously manages to retain 97% of the full model's language understanding. Trading a measly 3% of accuracy for massive operational gains, that is a deal you want to take every single time in MLOps, especially when you're building an API.
And here's where those gains really kick in. Despite performing nearly as well as its bigger sibling, DistilBERT's 40% smaller in size. Shedding almost half of a model's weight? That literally transforms your infrastructure requirements. It saves memory, it saves network bandwidth, and it saves you a whole lot of engineering headaches down the road.
But wait, it gets even better. It is 60% faster. Think about the end user for a second. When someone submits text to see if the sentiment is positive or negative, they expect a result instantly, right? A 60% speed increase is literally the difference between an app that feels clunky and sluggish and one that feels incredibly snappy.
And this brilliantly illustrates how those early architectural choices impact the final product. Because of those wild numbers we just went over, the SENTINALysis project benefits in 3 huge ways: smaller Docker image sizes, way lower memory consumption on the host machine, and significantly reduced API latency. It's really a masterclass in just choosing the exact right tool for a production environment.
Section 2. Training the sentiment engine.
All right, now we move into the actual manufacturing process, teaching our model to understand sentiment. The MLOps progression that the repository outlines runs locally using Hugging Face, and it goes exactly like this. Step 1, pre-process the data. You can't just throw raw text at a model, it needs to be formatted. Step 2, fine-tune the model on that prepared data. And step 3, once the model is trained up, you containerize the whole result with Docker. Let's break down exactly what we need for those first 2 steps.
Before we hit start on this assembly line, we've got to grab our toolkit. The developer specifies Python 3.10 or higher and heavily recommends a virtual environment, which, let's be real, is a crucial best practice so you don't completely clutter up your system. From there, you just install the essentials. We're talking pandas and scikit-learn for moving data around, the Hugging Face transformers and datasets libraries for the model itself, and PyTorch to handle the heavy deep learning backend.
With the environment all prepped, the very first command you run is the preprocess.py script. This script basically ingests the IMDb dataset, which acts as the raw material for our sentiment engine. And actually, there's a fantastic little feature here for developers. If you just want to verify the pipeline works without staring at a progress bar for hours, you can toss in a --numsamples20 flag to process just a tiny chunk of data for a quick test. Super handy.
Next up is the heavy lifting. Running train.py kicks off the fine-tuning of the DistilBERT model. This is where the magic happens, where the model actually learns the nuances of human sentiment from our data. The documentation points out that this script does 2 vital things when it finishes. It logs performance metrics to a results directory, and crucially, it saves the final model artifacts to a folder called model output. And that model output folder, that is our golden ticket for the next phase.
Section 3. Deploying with Docker.
Welcome to the packaging department. Look, a finely tuned model just sitting on your hard drive isn't a product yet, right?
So SENTINALysis uses Docker to containerize it and get it ready for the real world. To set the stage, the setup instructions lay out a few strict requirements. First, obviously, you need Docker and Docker Compose installed. Second, and you cannot miss this, the Fast API Docker image expects those newly trained model artifacts to be sitting exactly in that model_output directory we just mentioned. If they aren't there, the build completely fails. Finally, you just copy the provided .env.example template to create your active environment config.
Once all those pieces are perfectly in place, this single line of text is basically the magic switch. Running docker compose up --build-d tells Docker to read the config, build the environment, package up the Fast API app right alongside our trained model, and spin the whole system online in detached mode. Boom! What was just a bunch of Python scripts a minute ago is now a robust, running server.
And the repo doesn't just give you one way to interact with it, it gives you two totally distinct access points. For product managers or end users who want a visual experience, the system spins up a nice web UI accessible right in your browser on port 8501. But for the engineers out there who actually need to integrate this service, it simultaneously hosts interactive, developer-friendly API documentation on port 8000. It really just caters perfectly to both audiences.
Section 4. Making real-time predictions.
All right, the factory has produced the goods, and now we get to act as the consumer interacting with the live REST API. Now, what's really interesting here is how beautifully simple this interface is. To ask the system to analyze sentiment, we just fire off a standard POST request to the /predict endpoint. The paylog? It's just a tiny piece of JSON with a single key called text containing the string we want analyzed. Like, I absolutely love this new feature. And almost instantaneously, seriously, thanks to that lightweight DistilBERT model, the API fires back its analysis. The response is this incredibly clean, structured JSON. It categorizes the sentiment as positive, and which is crucial for downstream apps, it provides a confidence score. In this case, it's 99% sure of its assessment. This kind of structure makes it so incredibly easy to wire into literally any front-end dashboard or application.
But the developer didn't just stop at real-time single requests. No, for larger analytical jobs, they threw in a standalone script called batch_predict.py. You basically just point this script at an unseen CSV file containing a text column, and it will churn through the entire document, automatically appending new columns for predicted sentiment and confidence right into the output file. It is a highly practical addition for bulk processing.
So we've seen how SENTINALysis takes raw data, rigorously fine-tunes a highly optimized model, containerizes the result, and serves it up through a dual-interface REST API. It is honestly a pristine example of modern machine learning architecture in action. So I want to leave you with this thought. Looking at the structured, factory-like precision of this workflow, how might you integrate an end-to-end MLOps pipeline like this into your own software projects? How do you bridge that gap between a simple local script and a true production-ready application?